this video, we're going to look at balancing chemical equations. During chemical reactions, atoms of the reactants are rearranged to form the products. No atoms are created or destroyed, therefore there should be the same number of atoms on both sides of the equation. It must be balanced. Here are the rules that you should follow when balancing chemical equations. So you can't change subscript numbers. This means the small numbers in chemical formulae can't be changed. So you can't change the number of oxygen atoms in one molecule of carbon dioxide. Next, you can only add whole numbers. So you can only add numbers in front of each reactant or in front of each product, and they can only be whole. So this could be a 2. You wouldn't have your final answer as 2.5, for example. This is wrong because you can't have half of a carbon dioxide molecule. And then you can't split compounds or molecules. Now, this is something I've seen students do many times, is split a chemical formula into 2 parts and then add a whole number between them. This is wrong. You can't do that. And then the final rule is that the number of reactant atoms has to equal the number of product atoms. So if we have 1 carbon atom on the left side of the equation, or the reactant side of the equation, there has to be 1 atom of carbon on the product side of the equation. Our first example is going to be magnesium plus oxygen gives you magnesium oxide. So the first step of the procedure is to draw a line underneath the arrow to separate the reactant side from the product side. Then we want to list the elements on the reactant side, and then we want to copy this list onto the product side. And it's good if you do this in the same order, magnesium, magnesium, oxygen, oxygen, because then it will be easy to compare the number of atoms you have on both sides of the equation. So then we want to write down how many atoms we have of each element. So on the reactant side, we have 1 atom of magnesium and 2 atoms of oxygen. And on the product side, we have 1 atom of magnesium and 1 atom of oxygen. So then we identify what's not balanced. And as you can see, the number of magnesium atoms are the same, but the number of oxygen atoms is not the same. So what could we do to this magnesium oxide to have the same number of oxygen atoms as the reactant side? We can multiply the whole thing by 2. And if we do this, now we have 2 oxygen atoms. But as well as changing the number of oxygen atoms, we've also multiplied the number of magnesium atoms on the product side by 2 as well. So we need to fix that too. So now there's an imbalance in the number of magnesium atoms. So now we would add a large 2 in front of the magnesium on the left side of the equation. And now we have a balanced chemical equation. So your final answer would be 2 Mg plus O2 gives you 2 MgO. This is not the answer. This is part of your working out. Our next example is going to be sodium plus oxygen gives you sodium oxide. So once again, draw a line underneath the arrow. List the elements on both sides. Write down the number of atoms that you have on both sides of the equation. And then identify what's not balanced. And in this case, both elements are not balanced. So we can add a 2 in front of sodium oxide, and that will give us 2 atoms of oxygen. So now the oxygen's balanced, and we've multiplied the number of atoms of sodium by 2, so now it's 4. Now we can add a 4 in front of the sodium on the reactant side of the equation, and now we've balanced the equation. Our next example is lithium plus water gives you lithium hydroxide plus hydrogen. And we have to be careful here because hydrogen is in both of the product chemicals. So we need a total of 3 because there's 2 in the hydrogen molecule and 1 in lithium hydroxide. And now we need to identify what's not balanced. As you can see, the hydrogen is not balanced. So what I'm going to do here is add a 2 in front of the lithium hydroxide. This will make the total number of lithium atoms 2, the total number of hydrogen atoms 4, because now we have 2 in lithium hydroxide and still 2 in the hydrogen molecule, and this will make the number of oxygen atoms 2. Now we can add a 2 in front of lithium to make this 2, and we can add a 2 in front of the water molecule to make the number of hydrogen atoms 4 and the number of oxygen atoms 2, and then we've balanced the chemical equation. Our next example is going to be methane plus oxygen gives you carbon dioxide plus water. Now the hydrogens aren't balanced and the oxygens aren't balanced. So what I'm going to do here is multiply the water molecule by 2. This will balance the number of hydrogens, and this will bring our total number of oxygen atoms to 4. And then I'm going to add a 2 in front of the oxygen on the reactant side to bring the total number of oxygen atoms on the reactant side to 4, and then we've balanced the chemical equation. Our last example is calcium plus water gives you calcium hydroxide plus hydrogen, and this is slightly trickier because the calcium hydroxide has brackets. Now, as you can see, the number of hydrogen atoms is not balanced and the number of oxygen atoms is not balanced. And we can fix this by simply putting a 2 in front of the water molecule. And this will bring the total number of hydrogens to 4 on the left and the total number of oxygen atoms to 2. And then we've balanced the chemical equation. Now I want you to pause the video here and try to balance these 6 chemical equations. Here are the answers. Like the video if you got 6 out of 6.